Hi there. Thank you all for joining us today. I'm Hunting Buckley, and I lead the global strategy for games here at Databricks. Really appreciate y'all coming out. For those of you that are watching this virtually down the line, thank you for watching this virtually. Have the pleasure of introducing Justin, who is the director of data for Second Dinner, and he's going to talk about how they are modifying the player experience with data and how important that is to what they do for their players. If you've never heard of Second Dinner, they made a small game. It's called Marvel Snap, right?
Yeah.
Yeah, that's that game. Now, amazing people, really looking forward to hearing what Justin has to say. And with that, thank you.
Cool. Thanks, Hunting. Yeah, thanks. Also, thanks everyone for coming here. I know it's the last day. We're all tired, but yeah, hopefully this will be short and interesting. So yeah, let's kick this off. Here's the forward-looking statement. I'm sure you've all seen this many times. I'm not going to read through it. Just know that everything I say here, kind of my own thoughts and opinions. Cool, let's jump into it. So I'm going to talk about how we're using data and Databricks to sort of enhance the player experience. All right, so quick introduction about myself. My name is Justin Wu. I am the director of data at Second Dinner. Second Dinner is a small game studio based in Irvine. Founded in 2018, we have a product, a game called Marvel Snap. Marvel Snap is a mobile card game. Unlike traditional card games, instead of like battling and killing your opponent's cards, you're presented with 3 locations. The players play cards at each of the 3 locations and accumulate points that way. And then sort of at the end of the game, whoever has more points at 2 or more of the 3 locations wins the game. Right, so you don't need to memorize all of that. Just know that it's a mobile card game. Cool, so we recently completed the Unity catalog migration. We did a few other things. Most of our workloads and jobs are on serverless now, instead of the traditional clusters or job clusters. And we kind of have our ducks in a row with regards to the data platform and the data engineering side of things. It's not perfect, but we're pretty happy at where we've landed. So the question is, now that the platform is, the platform improvements are done, what's next, right? How do we want to really unlock the power of what data can do for us? So here's a few use cases that are either implemented or kind of an ideation stage. The thing that all of these share, that none of them leverage the Unity catalog and the serverless workloads yet. So they're either on kind of the old Hive Metastore, or they're being done manually. So later on, I'll kind of dive into one of these and look at a brief case study. But before we do that, we're going to talk about architecture a little bit. So I got some feedback that my slides were a little technical, so I won't go super in depth in them. I think some engineers might be disappointed, but I'll keep it high level. So this is what kind of our current setup looks like. I won't go into detail about each of these. I think the main thing to take away here is that our current setup has sort of 2 AWS stacks, right? And they are managed, we use IAC via Pulumi. They are managed by different stacks and different repos. One is managed by backend, one is managed by the data team. Cool, so this setup works, right? So if you saw the flow, let me go back. So there's some ingestion processes, we do some Databricks stuff, put it back into AWS, and then try and get it back into the game. So this setup works. But there are some issues, right? So I mentioned the 2 sets of AWS systems, but in addition, some of AWS's offerings work, but maybe aren't perfect. So for example, the SageMaker feature store, right, is really just a kind of a glorified DynamoDB. In fact, I think it's based on the same tech. So that comes with all the limitations that Dynamo does. In addition, because we're kind of moving data out of the Databricks systems, most of our data users are very familiar with Databricks, using Databricks notebooks, the SQL editor, orchestrating jobs in there. But once you kind of move that out of Databricks, for them, it feels like the data has just gone into a black hole, right? So it's kind of like a make your ETL and then kind of like pray and hope that the data ends up where you want it to. Cool, so let's throw all that out the window for a second and talk about what we're really trying to do, right? So let's get rid of the implementation details and kind of abstract the process. So it's pretty simple, right? It basically falls into a reverse ETL process. So we do something to get the data from the game. Once we get the data into Databricks, we process the data in Databricks. And then we need to find a way to send the data back to the game or make it available. Cool, so with that, this is kind of our simplified architecture, right? So we explored a lot of offerings that Databricks had. I'll go into more detail on some of them in a bit, but it turns out that Databricks can now support a lot of the features that were kind of exclusive to AWS in the past, right? So now instead of having to manage 2 Databricks stacks, or 2 AWS stacks, we can still let AWS handle the ingestion through Kinesis and Firehose, but the processing and the serving can be done in Databricks, right? In addition, I think Databricks for these use cases is a little bit more feature-rich, right? So it solves some of the pain points of DynamoDB and the feature groups. And then in addition, because we're keeping everything in Databricks, the data scientists, the product managers can now kind of validate that the data has worked or is there without having to, remember which AWS account that it is supposed to land in, which region it's supposed to land in, and they can just kind of verify the results within Databricks. Cool. So let us dive into a bit of a case study. So just to keep it kind of simpler and at a high level, we're going to look at kind of how that framework I just showed fits with a recommendation system. Though this is really, because this is such a general framework, it kind of works with all of the use cases I mentioned earlier. Cool. So getting the data from the game, thankfully we have some telemetry pipelines already instrumented. We managed to move them onto Unity Catalog, so our raw data, our bronze layer, our silver layer was within Unity Catalog. So when we started building the recommendation systems, we kind of had, we had a lot of features that we could pick from. So we wanted to narrow down the scope to, and we may add more in the future, but we wanted to narrow down the scope to a couple of like features or player features that would, that we could serve recommendations from that would really engage with the players. So some basic ones here are, their ownership, right? We don't want to recommend them the same cards. We kind of want to look at their purchase history, maybe give more weighting to what they've purchased recently. And then in addition, kind of maybe ignoring the player aspect, look at more trending or meta cards, right? So we're using autoloader to ingest the data and Airflow to orchestrate the jobs. Some considerations here, right? Because this is what I consider still in the realm of like data engineering or feature engineering is looking at the ingestion frequency and data cleansing, right? We don't want dupes. And when we do create these pipelines, we want to make sure they're as fresh as possible, right? Because players move very quickly. They may purchase cards that you were going to recommend, and now your recommendations are stale. Cool. Moving on, so processing the data within Databricks. We had to come up with a hypothesis on how we wanted to recommend these cards to players, right? So, I think the obvious sort of thing to optimize for is revenue, but there might be additional considerations. Right? Is it solely revenue, is it short-term revenue, or do we want to push players to maybe branch out, explore different play patterns? All of that needs to be kind of taken into account. Once we have that hypothesis and the goal, train and score the model, we've tested out different algorithms, different approaches doing this. People much smarter than I are currently iterating on it. So I'm not going to talk too much about the algorithms used. But regardless of which approach we choose, we're generating the recommendations in batch. Right, and kind of the way that Databricks assists us here, right? We're using notebooks to prototype and iterate quickly, and then once we have an idea of what production looks like, we submit them as Spark jobs through Airflow. Cool, and then the final piece of the three, sending data back to the game. So I guess kind of regardless of which system we use, whether it's AWS or Databricks, the first thing we have to do is split the batch recommendations by region, right? Because we want low latency when it comes to showing the players these recommendations, right? And then figure out a way to sort of enable external systems, whether it's backend or some other microservice, to essentially access these batch-generated recommendations. So to do that, we're using Unity Catalog and the online tables with workspaces spun up in the local regions. Cool. And then some key metrics here that we're still currently investigating are kind of the response time and region availability. So AWS regions, lots of availability. I think Databricks is getting there, but they don't map one-to-one with AWS regions at the moment. Cool. So with that said, here are some learnings and takeaways that we've kind of noticed along our journey. So the first is that project planning and stakeholder alignment is extremely important, right? So I kind of like to break these projects out into a three-phased approach, right? So discovery, design, and implementation. The idea behind discovery is by the end of this phase, we should have a yes or no answer on whether this is technically feasible, right? Because if it's not technically feasible, then everything else is moot, right? So during this process, we kind of want to POC the new technology and come up with an architecture, design, or proposal. Really answering the question of, can we do it? So then, if the answer is yes, and we move on to the design phase, the question we should be answering is, should we do it, right? Now that we've shown that we can do it, does it make sense? Cost-wise, latency-wise, does this make sense to embark on, right? And then I think what we've learned is that during this phase, we should start to kind of broach the topic of stakeholder alignment, right? Not just like asking stakeholders, is this a good idea, but getting a concrete plan of what do timelines look like? Are there engineering resources to dedicate to this? And then once we answer that, implementation should be fairly straightforward. It's just doing it. And hopefully all your plans are in place, all your timelines are agreed upon, and the details really just come down to implementation nuances. So where are we in this journey right now at Second Dinner? So discovery, yeah, we've proved that we can do it. In fact, we have a pretty good pipeline going on right now. So we're kind of keeping the old pipelines. We move the data processing onto Unity Catalog. We're still sending to SageMaker, but during that phase, we're also forking the data to the Databricks online tables. So testing, integration testing can happen with backend on Databricks. We're currently in the middle of our design phase. So what we're looking at now is cost and latency, essentially. So per call, SageMaker is very cheap, right? So one of the questions we do have to answer is, what does that look like on Databricks, right? Does the pros of simplifying our architecture, is that worth potentially an increase in cost? Maybe Databricks is even cheaper. We don't know that yet. And then there's the latency issue with region availability that I mentioned earlier. So these tests are ongoing. And then obviously, because we're still in the design phase, implementation is still TBD. Cool, so the other thing that we've learned is that sometimes data alone isn't enough, right? Just because we can generate these recommendations doesn't mean we can get these features in front of players, right? So engineering resources, back-end engineering resources, front-end engineering resources are scarce and invaluable, right? The data org is part of the tech org, but we don't control the back-end engineers' roadmaps and times, right? So to do a lot of this stuff, we have to get alignment in advance. Even once we get these resources, right? To make these player-facing, we kind of have to align with broader org processes, like release changes, branch cuts, when we upload our build to the Apple and Google stores, right? All of these take time, and once we miss a deadline, often it's very difficult to go back and hotfix that. Sometimes impossible. So what are we looking at next? So we know that we can serve features, right, through the online tables. Talking to our Databricks reps recently, we also learned that they're releasing some model serving features, right? So what does this sort of unlock for us? So if traditionally we let backend handle most of the logic and data just supplies the data, with this, we can push a lot of the logic to data, right? So for example, let's say there's 5 slots for recommendations. We want to generate 6 recommendations just in case that the player has already purchased one of our recommendations, right? This logic on finding what they own, which of the 5 of the 6 recommendations to show, that's all handled by backend. If we wanted to expand that to 7, 8, 9 recommendations, all of those require backend changes. Let's just let data handle that instead, and let's just provide a contract with backend saying, hey, we'll always give you 5 cards, 5 recommendations. It doesn't matter what they own or what's happened. We'll be the ones responsible for that logic. And once we move to model serving, this also unlocks something we've been desperately trying to do for a long time, which is A/B testing. So we can have the smartest people in the world. We can have great hypotheses about which model was going to be better, what's going to perform better, but without testing and sort of these data-informed results, you're never quite sure, right? Moving to model serving will allow us to upload different versions of the model, seamlessly switch between them, generate flags for players for their experiment group. So we can roll out a new model to 10% of players, see what the response is like before choosing to productionalize it or push it to production. Cool. That concludes my talk. Like I promised, short and sweet. Don't forget to fill out your surveys, and I will probably step to the side for a few moments for Q&A if there are any Qs.